Finding values of logarithms. Here we have a few numbers in logarithmic form. So what's the values of these logarithms of 2 base 2, logarithms of 4 base 2, logarithms of 8 base 2, and logarithms of 16 base 2? So how do we know the values of this number? Now, we know that for a logarithm number, this is the base, and the meanings of this number is 2 to the power of what equal to 2, right? 2 to the power of what equal to 2, and in index numbers, we know that 2 to the power of 1 equal to 2, and therefore this is equal to 1. Okay. So this is how we find the values of logarithms. Let's see another example. 2 to the power of what equal to 4? We know that 2 to the power of 2 equal to 4, and therefore the logarithms of 4 base 2 is equal to 2. So 2 to the power of 3 equal to 8, and therefore this is 3. And 2 to the power of what equal to 16? We know that 2 to the power of 4 is equal to 16. So this is how we find the values of logarithms. Okay, let's see a few special logarithms. For example, the logarithms of a base a. Now let's see some special logarithms which we can straight away tell us their values. Okay, so logarithms of a base a. Now in index numbers, we learned that a to the power of 1 is always equal to the a, no matter what's the values of a. Okay, so therefore we can straight away tell that a to the power of 1 equal to a, or the logarithms of a base a is always equal to 1. How about this one? So a to the power of what is equal to 1. And in index number, we learn that a to the power of 0 is always equal to 1, right? No matter what's the values of a, okay? And therefore, we can straight away tell that logarithms of 1 base a can be any numbers, is always equal to 0, okay? And the last one, a to the power of what always equal to the a to the power of x. Of course, a to the power of x is always equal to a to the power of x, right? Okay, so for this logarithm, we can straight away tell what's their value. Okay, now for the last one, let's say we have log a to the power of 2. We can straight away tell that this is equal to 2 because a to the power of 2 equal to a to the power of 2, right? Okay, so this is some examples of special logarithm which we can straight away tell us the answer. Now there are a few important notes that we need to know about logarithm. The very first one is the logarithm of a negative number is not defined. For example, if you encounter this log with any base, negative 2, okay, now this is undefined. Okay, yep, because we can't get a to the power of anything to become negative 2, because an index number a to the power of anything is always equal to a positive number. It's always equal to positive numbers. You won't get a negative number for this, and therefore the logarithms of a negative number is undefined. Okay. Now, if we would like to solve or find the answer for numbers in logarithms in calculator, then you need to know that the log in the calculator denotes log base 10, or the common logarithms. The logarithms with base 10 is called the common logarithms. Okay, so in calculators, the log is always refers to the log base 10, or the common logarithms. And when you answer any questions, the log base 10s can be written as just lg without the o. This is log log. But if the base is 10, we can straight away write lg, and this indicates that the base is 10. Okay, so you don't need to write log base 10. Okay, you can just write LG. Yeah, this denotes log base 10. And if the base is other than 10, then the base should be specified. So for example, if we write log 3, okay, so this indicates that this is log base 10 3, or we can write this as LG3. Okay, if the base is not 10, then you have to tell what's the base. So let's say if the base is 3, then you have to indicate here 3. Okay, so log 3 3. Yep. Okay, if it's not written, then we will assume that the base is 10. Okay, let's see this example. Find the values of x in the following. A, so we have log 3 x equal to 3, and hence we know that in index form this is 3, the base is 3 to the power of 3, this one, equal to x, and therefore x equal to 3 times 3 times 3, and this is equal to 27. Okay, so this is how we find or we solve an equations that involve logarithms. Let's see question B. So we have 1 over 2 equal to log base 9x, and straight away we can tell that this is the base. 9 to the power of 1 over 2 equal to x. When we learned index number, we know that if the index is in fractions, this shows that this is the root. Okay, this is a root. And if the denominators of the index is 2, and this is the square root. So 9 to the power of 1 over 2 is equal to the square root of 9, equal to x, and therefore x equal to 3, or a positive 3 or a negative 3. Okay, and then question C, log 4 base 4 x equal to 0, and we know that x equal to 4 to the power of 0, and 4 to the power of 0 is always equal to 1. So x equal to 1. Log base x 216 equal to 3. So the base is x, so x to the power of 3 equal to 216. And by doing some calculations, you should know that 6 to the power of 3 is equal to 216, and therefore x is equal to 6. Okay, so this is how we solve the problems or solve an equations that involve logarithm.